Welcome to chemistry. Today's lesson is on the stoichiometry of compounds, part 3, determining empirical formulas. Previously, you've learned to convert from grams to moles. To do this, we take the number of grams of a substance and divide it by the molar mass of the substance. To calculate percent composition of a substance. To do this, we take the number of grams of a particular element in a sample of a substance by the total mass of the substance, and we do that for each element found in the substance. In this lesson, we'll be covering the following: the difference between empirical and molecular formulas, how to determine the empirical formula of a compound from percent composition or analytical data. There are two types of formulas that we encounter in chemistry. Empirical formulas. Empirical formulas are the simplest ratio of atoms in a compound. Both ionic compounds and molecular compounds can have empirical formulas. This other type are molecular formulas. A molecular formula represents the actual types and numbers of atoms found in a molecule of a molecular compound. Only molecular compounds can have molecular formulas. Determining the formula of a compound involves the following process. First, we have to convert the mass of each element present into moles. We do this by dividing the mass of each element present in the compound by its molar mass. Secondly, we find the simplest ratio of the moles of the elements to each other. We do this by dividing the result from step 1 for each element by the smallest result from step 1. Round the result to the nearest tenth place. If integers result, these are the subscripts for each element in the empirical formula. However, if integers do not result, we need to choose a single factor that when multiplied by each of the results will yield an integer. Use the same factor for every result from step 2. All right, let's look at some examples. First, we have a sample that's analyzed and found to contain the following elements in these masses: 11.47 grams of nitrogen and 1.653 grams of hydrogen. So we're working with nitrogen and hydrogen. We'll convert each to moles. We take the nitrogen and divide it by the molar mass of nitrogen, which is 14.01, which gives us a result of 0.8187 moles of nitrogen. 1.653 grams of hydrogen divided by the molar mass of hydrogen, we'll use 1.01, gives us 1.637 moles of hydrogen. Now we need to take each of these numbers and divide each by the smallest of the two. So we'll select the 0.8187. 0.8187 divided by 0.8187 is equal to 1. 1.637 divided by 0.8187 gets us 2. And so our formula ends up being NH2. 2 moles of hydrogen for every mole of nitrogen present. Example 2, again we have a substance analyzed and found to contain the following elements in masses of elements: sodium 1.48 grams, sulfur 1.03 grams, and oxygen 2.06 grams. So we've got sodium, sulfur, oxygen. 1.48 grams divided by 22.99 gets us 0.0644 moles of sodium. 1.03 divided by 32.06, which is the molar mass of sulfur, gets us 0.0321 moles of sulfur. And finally, 2.06 divided by 16, the molar mass of oxygen, gets us 0.129 moles of oxygen. Now, the smallest of these is 0.0321, so we'll divide all of these results by that factor, 0.0321. So 0.0644 divided by 0.0231 gets us 2.0. 0.0321 divided by itself gets us 1. And 0.129 divided by 0.0321 gets us 4.0. And so sodium will have a subscript of 2, sulfur will have a subscript of 1, and oxygen will have a subscript of 4. So our formula is Na2SO4. There are 4 moles of oxygen for every 1 mole of sulfur and for every 2 moles of sodium. Our last example is going to be using percent composition data. We've analyzed the substance and determined that its percent composition is potassium 26.58%, chromium 35.35%, and oxygen 38.07%. These percentages can be converted directly into grams by considering a 100-gram sample of the substance. 26.58% of 100 grams would be 26.58 grams of potassium, and we do the same for chromium and oxygen. So beginning with our three substances, 26.58 grams of potassium divided by the molar mass of potassium, 39.10, yields 0.6798. 35.35 grams of chromium divided by the molar mass of chromium, 52, yields 0.6798. And finally, 38.07 grams of oxygen divided by the molar mass of oxygen, which is 16, yields 2.379. Well, it looks like 0.6798 is going to be our smallest number, so let's divide each of our results by that factor. 0.6798 over itself is equal to 1.0. 0.6798 over itself is equal to 1.0. And 2.379 over 0.6798 is equal to 3.5. Since we haven't gotten an integer value for the number of moles of oxygen, or the smallest ratio of moles of oxygen to chromium and potassium, we need to choose a factor which we can multiply by all three of these numbers in order to get a whole number. Well, obviously 2 would be a good choice. And so 1 times 2 is equal to 2. 1 times 2 is equal to 2. And finally, 3.5 times 2 is equal to 7. So our formula ends up being K2Cr2O7. So, to recap, to determine the empirical formula of a substance, first we convert the grams of each element in the substance into moles. We do this by dividing each mass by the molar mass of the element. Next, we find the simplest ratio of the moles of the elements in the compound. We do this by dividing each number of moles by the moles of the element with the least number of moles. So we take the smallest result from step 1 and divide it into the other results from step 1. If it should turn out that we don't get an integer number, we will have to multiply by a factor which will take us to an integer number. Next time, we'll do determining molecular formulas.